in general, this was our approach. We are going to be aggressive also about partnerships, even though the partners could compete and overlap,
Mm.
because you have to trust yourself that at least when it comes to Spark, you can build the best products. We are, kind of saying internally, well, if someone else is building a better product for Spark than we deserve to lose, right? So that's kind of always was the confidence that we can build the best product for Spark, and eventually, if Spark wins, we are going to win.
Hi, everyone. Welcome to Training Data. Today, we're excited to welcome Ion Stoica, professor of computer science at UC Berkeley and co-founder of both Databricks and Anyscale. He has a uniquely exceptional career as a leading professor and founder of companies at truly legendary scale. Today, we dig into questions like Databricks positioning in AI, how research projects like Spark and Ray have led to the founding of Databricks and Anyscale, how he ties his research projects closely to industry from day one, new projects out of his lab like VLLM, MemGPT, LMSys, and Vicuna, and what research fields he's thinking about next. Jan, thank you so much for joining us today. We're really excited to have you on the pod. To kick things off, we'd love to hear a little bit about where Databricks aspires to fit into the overall ecosystem, especially with some of the recent launches. What are you personally most excited about?
First, thanks for having me here. So, I think with Databricks, always we wanted to um, provide the platform, an end-to-end platform, which helps our customers get most of the value out of their data. And one of the best ways today to get value out of the data is using these kind of new developments in AI, including large language model and everything else. And the one thing is that to note that this was always our vision from day one. Actually, Spark was created. One of the main reasons to create it, Mosaic, when build it, it was to solve, to speed up classical machine learning algorithms, right? Um, and to scale them up,
Yeah.
right? And so, in some sense, for us, it's full circle. We started with AI with machine learning. It's classic machine learning, and right now we are back and doing more and more AI because to take advantage and to create value out of the data.
So you mentioned that, you were founded around, enabling classical machine learning.
Yeah.
How do you see the current AI moment as same and how do you see it as different? And I'm curious, what are the specific things you're doing for this moment in time, like the Mosaic acquisition, things like that?
Yeah. So certainly the momentum around AI, it's on a different level
Yeah.
today, right? You just look at the investments out there, right? That should tell the you know uh, big part of the story. So I think that obviously is like um, what the way we are looking at is that uh, taking advantage and being successful with AI um, is not easy, right? It's like the AI ecosystem is growing in complexity. It's not just a simple call to a model, right? You have so many techniques now, like RAG and Raft, and right, to improve the accuracy of your application using AI, right? Obviously, everyone is excited about AI because it solves so many problems and there are so many, generate so many headlines. But still, it's not what you want. You want a product of AI. A lot of things still we are seeing today are fantastic demos, right? And demos are inspirational. And when people see demos, whatever ChatGPT solves this kind of problems, Olympics math problem, it's very easy to think that, wow, doing that is going to do everything, right? So, but going from demo to production, like I said, it's a big step. A demo means that you need to find an instance, at least an instance, to be really impressive, right? In production, so it's like, is there exists such instance, right? But when you go from the demo to the product, when you have a product, it has to work for all cases, right? So that's kind of the big gap. So that's why where the effort is to improve the accuracy, improve reliability, of course, eliminate hallucinations as much as you can. Uh, and really also to find where it provides the best value, because, you can apply AI to 1,000 use cases, but which are the use cases which are going to provide you the biggest value? I think that's what we are also trying to help our customers with. So to navigate that, how to successfully apply AI to their product, to improve their services, to their business.
In that vein, one of the most interesting things that I thought came with the Databricks AI launch was the new open general purpose LLM created by Databricks, Dbricks. What was the reasoning behind training your own models, open sourcing them, and what do you think are some of the best use cases for that model?
Yeah. So I think the main, if you look at like our main market, it's enterprise and
Yeah.
enterprise customers. They do have a lot of concerns about data privacy, confidentiality, and obviously they kind of want control. It's not only that, they want auditability, right? They want to be able to audit what data is used, what results have been used, and what decision have been made with what data the decision have been made. And so that's why, in general, the enterprises, everything being equal, migrate towards the open source models. We can host, on their machines or in their VPC and so forth. So it's one of the reasons for releasing the bricks is to help our customers. And then the customers say, in many of these cases, they start from this model and then fine tune with their own data and to optimize for their particular use case, right? So, and it's again, so our enterprise customers, they want, open source models. They want kind of control, as much visibility as they can. Um, they want privacy and confidentiality, especially in the recent light of the breaches,
Yeah.
which are widely published. The other thing is that the DNA of Databricks has been open source. It's not only Spark,
Hmm.
but Delta and
Yeah.
MLflow
Yeah.
and many others.
Yeah. The other thing I thought was fascinating about Dbricks is its excellent programming abilities. What do you think
Yes.
has made it such a capable code model, especially even compared to something like CodeLlama 70B?
Look, I think obviously, it's about data and how you train it. And it's one thing, I think, one of the major Databricks advantage is Mosaic, right?
Yeah.
We have also the entire infrastructure for training. So we have not only about the data, but the entire infrastructure of training and fine tuning.
Yeah.
And that is make it much easier and most cost effective to optimize models for different use cases.
Hmm.
And obviously, the copilot programmability,
Yeah.
it's one of the very important use cases in enterprises, because software engineers are still very expensive.
Yes. Interesting. Yeah.
So making the people you have, and it's not only about that. It's like hiring top software engineering is very difficult,
Yeah.
right? If you are a large company, like maybe, I don't know, 4G or things like that. And so making those people productive, it's extremely important and critical for their business.
You mentioned Mosaic as a key part of the strategy. I guess, what do you think are your most important chess pieces in this kind of AI battleground? I imagine Mosaic is one of them. Um, and are most of your enterprise customers looking to train their own models? How does how does Mosaic and your other acquisitions fit in with your customer needs?
Yeah. So I think it's like um, there are a few enterprises who would like, which so it's pre-training,
Hmm.
and then it's fine-tuning and using the model in your own on your own hardware, in your own VPC, on your own machines. you rent it, you own. Um, so, and you may expect there are few which are doing pre-training, but there are still a few want to pre-training on their data. You have enough data. A lot of them, they want to do fine-tuning, right? Because look, if you are an enterprise, right, and a company, right, and you want to improve your business, right, what do you have? What do you have and which other don't? The thing you have which other don't, it's the data about your business, about your users, right? Right. So therefore, because this is something you have and others do not, you want to take advantage of that, right? So how do you take advantage of that? Again, there are many ways, and you try different ways to do it, right? One is about fine-tuning. You use that data, and you have an open source model. You fine-tune on that, right? The other one to use rack, right, and things like that, and so you are going to do any of those, but then you want to do like I said in your own VPC, right? To preserve security, to have to enforce security perimeter. You want to do it in order to protect confidentiality of your users, and obviously, right now, with GDPR, the California Consumer Privacy Act, and so forth, there are a lot of regulation. And the number of regulation is going to increase. So the fact that you can, having an open source models, you can fine tune, you can use RAG in your own VPC, it's very compelling value proposition.
And are you finding that most of your customers want to go that approach versus, OpenAI and the very powerful closed source models in the market?
I think enterprises, and still we are still early on, and there are many enterprises obviously using OpenAI for different use cases, different applications, and I'm sure OpenAI and Microsoft Azure will come with new products to provide better confidentiality, better security. But at the end of the day, what I was saying is that everything being equal, right? As an enterprise, I will prefer more control,
Hmm.
security, and strategic, right? It's like it's less kind of locking or thing like that, right? So so I think that's what we are saying. So if as open source models are going to catch up with the proprietary models, in particular in the use cases which matter for the enterprises, it doesn't need to be perfect, right? For all the particular use cases, you just need to be very competitive where it matters. Then, enterprises will prefer these solutions on which they have, more control and more secure.
And how far away do you think we are from that moment? Like, do you think we're there today where all else is equal, or when do you think we cross that
In
threshold?
terms of the open source versus proprietary, or
Yeah, open source being, on par, all else being equal for the core use cases.
um, so you have a lot of use cases, it's the open source plus the data. And right now the application are more complex. It's not just a call to a large language model. You have this kind of, it's what it called, you know, you compose, you have, application which build from many components. And that's what we call compound AI. Um, and so actually it turns out that if you can you can build an applications for doing recommendation or things like that, or or for programming for a particular copilot for a particular tool, you can actually do better than um, uh, even something like OpenAI on the latest ChatGPT, because you have more data. And the other things about Databricks, which I think there are also announcement about that, is that with a kind of Unity catalog and things like that, you have access, and also about the structure of the data, which helps you tremendously to improve the accuracy of your applications. right? So it's not only the model, right? It's everything else you have around it, and the quality of the data you feed it in.
Hmm.
So I think that's uh, it's is a data stupid, like you'd say, right? Like at the end of the day.
It sounds like control and security are two primary areas of things that enterprises really care about that you've noticed, and Databricks obviously has a tremendous advantage with having access to data as well to help these companies use
Control
models.
and security for the customers.
Exactly. Um, what about some other factors have you noticed that they also care about? Is how much does cost matter? How much does diversity of other models matter?
I think obviously cost is
Yeah.
important, and it's like this, right? First of all, you want to, it's initially the important thing is about the value,
Yeah.
right? Can you provide the value, right? It's like, so that's the first thing. And at that stage, cost is not as important,
Yeah.
right? And in here, actually, in some of these early stages where people also try to use the most powerful model like OpenAI and things like that. But once you cross that and you have a use case which you conclude that is good, add value to your business. Now you want to scale it up, right? And now you are talking about having more control and more security
Yeah.
and all of these
Yeah.
things, protect confidentiality of the data,
Yeah.
privacy of your users, and so forth.
Yeah.
And now basically people consider how they are going to deploy it. And this is where having multiple choices and having, like you said, more control, security, it matters. And where open source models and platforms like Databricks are very valuable,
Yeah.
right?
Yeah.
And again, it's also all the other components which are together in Databricks, like I mentioned, like Unity Catalog and everything else to increase the value of your applications.
Yeah. Super interesting.
I'd love to talk to you about compound AI systems. I think you guys probably coined or popularized the term, and it seems like that's a lot of what the industry is latching onto now. Maybe for our audience, can you explain what is a compound AI system and what are enterprises thinking about when they're building these?
Yeah. So a compound AI system it's basically consists of multiple components, multiple calls to large language models or agents. And it's very much you can think about when you write a program, you have multiple components. You have different function procedures to do different things. And then you then put them together to create the program. Um, the same is very similar here, right? You can use maybe one model to parse the data, to extract the data. You can use, and then you can use, for instance, depending of the prompt, you may use a model, if the prompt is about math problems, right? It's like, you can use one model. If the prompt is about maybe about programming, you may use a different model, right? Um, and then you may use, for instance, about formatting the result, right? That's another one. You may use it, for instance, now more and more you are talking about agents, and with agents you have to, you call external uh, services or functions like search, or you can use a calculator and things like that. So now you have different models. You can do a better job, and they are small models actually, to take the prompt and convert it to a function call, right? So that's kind of what it is. But the way to think about it is like this: the conceptually is like you write a program, has different components, and make it easier to develop um, and deploy and manage. The same thing you want to apply to AI applications.
So like a collection of smaller components that work together, where the sum of the parts is greater than the one monolith that you're
Yeah.
replacing.
I'd love to dive a little bit into the Databricks story quickly, which I think is an incredible, legendary journey over the last decade, but with a lot of nuances that I think maybe many folks don't yet understand. From today, it looks like you were building the right company, at the right place, at the right time. But the actual nuance is that Databricks was originally started originally for data scientists. It
Yes.
happened to cater well to machine learning workloads because of all the work that you were doing in data. And over time, you made the right strategic decisions to actually really grow with the AI market. Can you share a little bit of some of the learnings and journey that got you to where Databricks was today?
Yeah, I do think that, very happy to. I do think that a lot of it's also about being the right time and the right place and things like that. It's being lucky, or I think that's all of this is true. Um, and there are many things needs to go right to be successful. Some of the things you control, some of the things you do not control. When we started, indeed, we are focusing to build a product, a cloud product, hosted product for data scientists. Right, we have this kind of notebook, and we have provided hosted Spark, and we targeted data scientists, and we targeted data scientists. It was one of the reasons we targeted the data scientists because, again, we all have, like I mentioned, Spark early on, was also targeting machine learning machine learning workloads. And at that time, there were not many data scientists. It was
Yeah.
like 2013.
Yeah.
However, when you look around, most of the universities already have data science programs,
Huh.
right? Degrees. You're starting to offer data science degrees, and you're saying, okay, it seems a good, path forward, um, a good market. And I remember you're looking at LinkedIn to see how many data scientists are there, because for our users, not initially, there are not as many.
Thousands.
Especially when you compare the data with
Engineers.
database analysts
Oh,
and
yeah.
engineers and so
Yeah.
forth. He thought we build, and I think it was a reasonable good product. And then we started to grow quickly in terms of the number of customers. Initially, we had small customers, and uh, but then after and still the interactive analysis, the data science has been for a long time. It's actually one of the biggest workloads, in particular in
Yeah.
terms of revenue. Um, because the interactive workloads are priced higher than batch workloads. Um, and I remember that we sold to these companies to use Databricks, and they are aspirationally buying it to do data to the data science AI. And when after a few months we go to them, because we didn't go much earlier, because we saw that they are doing well. Their usage was growing and everything seems good. So no reason to worry. So we went back to them and said, to see what they are doing. Maybe we can write a blog post or whatever they're doing, right? It's like marketing and everything. The surprise is that very few are doing actually machine learning at that time. And we asked them what happens, right? Or still, well, it turns out that obviously that in order to do machine learning, you need data, like we
Yeah.
discussed early on. And they realized that for the particular applications they wanted, they don't have the data they need. So they need to now to put maybe to add new logs, to collect new logs in their products and things like that. And also they need to clean up the data, curate the data and so forth.
Yeah.
So now we are lucky because Spark was very good also for data engineering,
Yeah.
right? For data processing, right? It's a data processing tool at the end of the day. And so they are using Spark for data engineering.
Yeah.
And then obviously we start focusing also on serving data engineers much more than before. And that's how we started. And then obviously when later now got the data engineering right, and still have all these data scientists exploring and starting to build models, and then it is a very natural extension to start to add more products for our user, for our customers, like I mentioned, to get more value out of their data. And that meant building machine learning models and using the open source models.
Very interesting.
I want to talk about the Databricks Microsoft partnership. I think that was the stuff of legends, and I think still probably one of the only case studies of a successful, like truly transformative partnership. Maybe walk us through what that partnership was. Was it a bet the company moment at the time? Do you think Databricks would have become what it became if you hadn't struck that partnership? Maybe just talk about that.
Look, obviously the partnership with Microsoft was a great partnership for us. We are the one thing I want to say is that and this is most visible, we are very from the day one we are actually very focused on the partnerships. Our idea was always, like, we know we make um, Spark successful, hopefully de facto standard for data processing, and then we make Databricks the best place to run Spark. So early on, actually, we started, a few months in the life of the company, we had this kind of partnership with Cloudera. And then we had with Hortonworks. And this partnership was mainly because we are to advance Spark, right? Because Spark, it was created in Hadoop ecosystem,
Mhm.
right? And these are the Hadoop companies, right? Right. And so we had this partnership or data stacks and so forth. So
Yep.
this was like in the first year or so, we had all this partnership, despite the fact that some of these companies, we knew that they could become our competitors,
Mhm.
right? Because, just making and helping them um, to um, to deploy, to manage, and to sell Spark-based services, right? It's like um, so. So in some sense, the Microsoft is like it fits our um, kind of approach of trying to to strike as much, do partnerships with other, being aggressive, doing partnership with other organizations in the ecosystem. Even though, again, in some cases it was not a clear cut whether we are, they are going to compete with us or not, right? So you're very just growing the ecosystem and growing Spark. That was the priority. We even had at some point a partnership with Snowflake. So it was very, it requires a lot of heavy lifting. So we always look for partnership which are meaningful, right? And I think great negotiation, Ali and so forth did a fantastic job there. Um, but at the end of the day, we also need to commit to it. It's like it took to do to build the Azure Databricks. So we are an AWS before that. It took, tens of engineers 1 year, and you are a small company at that point. So it was a huge commitment and a huge bet also from our perspective to do that. And yeah, and we, I think engineering and everyone executed very well, and it was a successful product, right? And Microsoft was great partners, you know, and yeah, this is what happens. We are obviously a bit lucky, but in general, this was our approach. We are going to be aggressive also about partnerships, even though the partners could compete and overlap,
Mm.
because you have to trust yourself that at least when it comes to Spark, you can build the best products. We are, kind of saying internally, well, if someone else is building a better product for Spark than we deserve to lose, right? So that's kind of always was the confidence that we can build the best product for Spark, and eventually, if Spark wins, we are going to win.
Do you think that Databricks would have become the company it is today without that Microsoft partnership?
I think so. It maybe could have taken a little bit longer,
Yeah.
but yeah, I think so. Right? We would have still have a very good offering on Azure, um, like we have with GCP. It would have taken a bit longer, but I don't see any fundamental change in dynamics,
Hmm.
right? Because one of the advantage of Databricks, of course, is once Spark won, and we could provide the best product for Spark, we are in a very strong position. And compared with other clouds, remember that one of our advantage, like everyone else advantage, like Confluent and so forth, is that you can provide a service on multiple clouds, right? And multiple clouds is, multi-cloud has been, more and more very strategic for, especially for large enterprises.
Yeah.
We do not want necessarily to be locked in or to want the one choice. So yeah,
I love the confidence and conviction that you have in Spark and your own execution abilities internally, but that married with the practicality and aggressiveness of winning as a business and pursuing the right
yeah,
partnerships and doing whatever it takes to win.
yeah, yeah. I mean, you try to simplify things.
Yeah.
That's what I was saying. You like initially when we said like, look, like we have to make Spark win.
Yeah.
There are many. I remember we look at all these combinations.
Yeah.
It's like Spark wins, the product fails,
Yeah.
right?
Yeah.
Or Spark loses, but we have a product which is
Yeah.
successful, or both fail. No, that's
Yeah.
not very interesting. Or both are successful, right? And we convince ourselves that, um, you know, we need to bet on Spark to win because that's the most likely
Yeah.
way also for the product to win, again, for better or worse, right? But sometimes there could be many ways to success, right? And you, in retrospect, you cannot go back and and try other alternatives. Maybe there are better alternatives at that point, but it's important to commit to one
Yeah.
thing, which hopefully it's a reasonably good solution, a
Yeah.
good path forward, right?
Yeah.
Again, there are many passes to the peak, right?
Yeah.
The most important is to commit to one which leads to the peak, right? It's like not the shortest one, not the easiest one. It may not be, but it has to be one to get there.
And to the highest peak.
And that's why I said, okay, Spark has to win, right? And we have to build, the best need to be the best place for Spark. And then we are saying, to be the best place for data and
Yeah.
AI, we need to eventually we knew and we assume that if you are to be hugely successful, you are going to, to go beyond Spark,
Yeah.
right? It's like that's why the name of the company Databricks is not Spark Labs
Yeah.
or something like that.
Yeah. Yeah. Interesting.
So that's kind of you try to simplify it. Once you do that, then you start to execute. Okay, so you want to make Ray successful as an open source, so you want everyone to use it. So that's why you do Cloudera and try Hortonworks and so forth. So to do this partnership, because at that time there are other solutions. People knew that Hadoop MapReduce, um, you know these times have passed, so to speak. So they are talking about new systems.
Yeah.
There are like TES, which actually Hortonworks has this project and so forth.
Mhm.
So that was very important. And then it was also for data science, it was kind of when we bet, it's like it's a niche, and we saw that we can build the best product for it. Um, so so that's kind of you need to have ultimately confidence in what you bet on, right? You have to bet, right? Right, because you are a small company, right?
Yeah.
If you don't bet, how you are going to win, right? Everyone, right? And then you need to have some level of conviction, right,
Yeah.
to do it. And yeah,
I'd love to kind of pull on that thread and switch gears a little bit into tying a lot of the entrepreneurial path that you have with a lot of the academic and research background that were the roots for the beginnings of these companies.
yeah,
You have a very unique career as both a leading professor and a founder of multiple unicorn and decacorn companies. I don't think there's anyone who comes close to pursuing both disciplines at the scale of success that you have. Maybe specifically, Ray with Anyscale, or Ray to Anyscale, Spark to Databricks. Take us into your head. What is the process in which these research fields start to ruminate in your mind? When do you kind of continue to give them resources to develop? And then when do you know that it's the time to then start a company to pursue that in a better, more open and fast way?
that's a good but hard question. So I think that, and by the way, I like to preface to say that, to start with saying that it's obviously also a lot of luck involved, and being in a place at like Berkeley and having fantastic students and colleagues around you, you couldn't do without that, right? It's like it's their merit probably more than mine. So, but one thing I think is that I've been always trying to focus. It's on the problem,
Yeah.
right? And actually, when even to my students, I'm telling them is like one of the most important things you need to do is to figure out what problems you are going to work on,
Yeah.
right? Because it's like everyone which comes to Berkeley or these top schools, one thing they have in common, they are good problem solvers, right? They have good grade, good scores, write papers. Paper is about solving a problem. So therefore, if all of them are good problem solvers, the differentiator is a problem you are working on, right?
Yes.
So you start with that. And also, I think it's like in the, especially at Berkeley, it's you get exposed of kind of not only new ideas but willingness to take risk and get into new areas. In some sense, and this is what I like about Berkeley. If you look traditionally, Berkeley, among top schools, they are the first to open new areas. Is like, of course, the risk processor. It was with Stanford as well, but databases, networking,
Yeah.
sensor networks, even in open source with the Unix BSD, TCP/IP, right, part of the STB. So they are always kind of more, a little bit trying to experiment. So I
Yeah.
think that's kind of, that's kind of culture. I really resonated with it. And then the other thing what happened with Berkeley, we have these labs, which are like 5-year labs, which basically each lab has kind of a vision, and it's a group of faculty coming together which believe in that vision and with their students and try to make it happen over 5 years. And this has a lot of great impact, like all the way. This tradition started 40, 50 years ago with Dave Patterson, Randy Katz, and others. And they built, risk, RAID, redundant array of inexpensive disk. Now, network of workstation is commodity. This is, everyone is building now this huge cluster of commodity machines, servers, and again, and many more. So there are these kind of elements, and these labs it's a very strong relation with industry, right? Connections. They are funded. When I came, actually, this was one change happened. Before, these labs are also supported by government, in particular DARPA.
Ah.
But it was a point in which that kind of, at least that particular DARPA funding dried.
Yeah.
So, kind of when I came to Berkeley, there was this kind of, now we need to go and remember, getting and more money from industry. I remember from Google, first time we got, and it was unheard by then because they were asking for 500,000 per year, right? For 4 years. So, but we got, and this is we got. So now you have also this kind of very tight connection with the industry. It's a very good environment to see the problems,
Yeah.
right? To understand the problems, right? And then you can see that, and you try to think about also about, obviously, about trends, right? Because trends are important, right? You have to be aligned with these secular trends, right? You need to bet on the right trends because these are things you cannot change, right? Or it's very hard to change. So you are not aligned. It's not good.
Yeah.
And these trends, actually, there are multiple trends, and the multiple trends kind of open gaps between them, and these are kind of opportunities for problems. Like, for instance, for big data, it was clear you have more and more data, and the amount of data people collecting were just growing, right? It was pretty clear, right? It's like Google has seen that years before, and they built all these systems. But now everyone wants to emulate that, right? That's why Hadoop was created, right? And then you see, you start to see again. You look at that, and you are working in that area, and we are, we have all these Hadoop people coming to our retreats on these kind of labs, and we are, friends with them. And we started to see problems, and then you try to use them, and then you just, like, for instance, there are two things which happened with Hadoop. One thing is about a group in our lab. By the way, and the other thing, what happens in these labs, they are interdisciplinary.
Yeah.
Right? It was people, we are in this kind of rad lab. Was that? It was people from machine learning, systems, databases, networking, right? So there are these groups of Michael Jordan students which wanted to compete to this Netflix challenge. That Netflix released some data, basically, and ask for people to provide recommendations, come up with to build recommendation algorithm systems, so that, to beat their own recommendation. So they come to us and, okay, it's a lot of data. Can we do about it, right? We want to, and told them to do, yes, Hadoop, but Hadoop was very slow, right? Because and then but they put together something quickly for solving this problem, in which the data was kept in memory. The other thing I've seen, it's about, like, I have a previous company called Viva, and it's about its own analytics company. And kind of, it was very slow, and we tried to do it, it's like for ad hoc queries, and there is no way to do it. And again, keeping the data in memory was a solution. It's one solution. So that's kind of how it started. That's one thing, right? And you look at the trends. Yeah, it's obvious, right? It's like, on one hand, you have more and more data growing faster than the Moore's law. So you need to have, it's not going to fit on one machine, and therefore you need to use multiple machines. And then the only other question is that, are you going to have data sets that are going to fit, important data sets are going to fit in memory, right? It's like, that's kind of the first question. And they are, because people, when they are doing, for instance, ad hoc query, you notice that, and we look at the data from different Hadoop cluster from Yahoo and Microsoft and others, and we notice that in a lot of cases, actually, when you do queries and you're doing analytics, you're doing not on the very rare on the huge all the data. You do, say, for the most recent data. You want to see what happens yesterday, what happens last week, something like that. So once you get that, and you have a lot of cases in which the data is fitting in memory, and memory is still growing quite quickly at that time, that's, you're pretty, you connect the dots, right? And then it's about solving the problem. And the other thing is happens, and why they are related. I'm talking about academia and industry, because I'm telling, people, some people, there are people in academia push back and say, it's a lot of engineering here. This is not you should do in academia. But one thing is what I've always found, it is very satisfying. If you build a system, right, in a new area, and that system, it's used by other people, then you are in the best position to understand the new problems in that area, because people are going to use your system in different ways, right? And then you understand that, right? And going back, if you know the problem, you are also in a good position to solve it, right? So actually, it directly helps you with your research, right, to be ahead. Because otherwise, what is the choice? Where you are finding the problems, right? Of course, there are problems, very good problems in theory, which are not solved by, decades and so forth. But other things, what people do, they go to Google and Microsoft and so forth, spend time and to understand what the problems they have, right? Because to solve. But that's kind of a little bit unsatisfying, right? Because you go to someone to learn about their problems. But the question is, why don't people solve those problems? Maybe they don't solve the problems because maybe, they're not as important as their given time, and maybe, maybe for the right reasons, they are, too much in the future but this is a thing, right? It's you have to focus on the problem, and you have to focus on the trends. And the way they're connected, you want to solve a problem, ideally, which is going to be more important tomorrow than today.
What are the problems that you're most excited about right now? Like Spark, Ray, like what's going to be the next Databricks or Anyscale?
So a few things. So I still think that it will going to be a lot of work. It's right now what happens is that need to rethink most of the software stack. Why? Because it's, again, if going back to the trends, is that the demands of this application, in particular AI application and so forth, growing much quicker than capabilities of a single processor, a single node, even if you considered accelerators, right? So on one hand, this happens. On the other hand, the infrastructure becomes much more complex. You need to run that application not only on one node, but on many nodes. It's distributed. But it's not only that, it's becoming very heterogeneous, right? Because in order to bridge a gap between the demand and capabilities of hardware, people build accelerators. Like that's why NVIDIA is $1 trillion company, right? But now the infrastructure become even more complex, right? Is not only distributed, heterogeneous. When we started Spark, it was homogeneous. All the nodes are the same, some storage, some CPUs, that's all. But right now, look at the heterogeneity. You have NVIDIA, and you have many other. You have TPUs from Google. Every cloud, it's having their own chip. Right now, you have AMD and Intel say that it's everything. It's about AI, right? So that's kind of what happens. So now you have a huge gap between this application and this very complex infrastructure, just growing in complexity. And then it's not only about CPU, the compute; it's about networking. You have InfiniBand, and you have all of this, RDMA and so forth, right? So huge heterogeneity, and the software stack has to abstract away that complexity for the developers. There is no way around. You want a single machine, or you have this operating system to abstract away the complexity, right? That's what makes it easy, right?
Yeah.
To develop all this application. Now it's extremely hard. So
Yep.
something is going to happen there. I think the other one is about this building application. You're talking about compound AI. We're talking about compound AI and things like that. Right now, this AI application, in particular large language models, everyone is talking about large language models. The application are like assistants for humans, right? Humans are in the loop, right? If you are thinking about customer support, if you are thinking about Copilot, if you are thinking about Q&A, question and answering, even summarization, you have a human helping a human to be much more productive, which is a fantastic application. But they cannot be autonomous. They are not yet autonomous. And to go from having the human in the loop to being autonomous is a huge gap, right? Because with autonomy, to have something autonomous, you need to have someone which, it's running kind of, it's more deterministic, it's more reliable, right? It's like far more accurate, right? Um, and you need to get there, because if you don't get there, you are still limited to having the system where the human is in the loop, and the human is a bottleneck. Will become the bottleneck. It's
Yeah.
it's just certain number of people on the planet.
Yeah.
And I think that there is about a lot of work will be about how to make, I would say, at least some aspects of this large language, building the large language model application more like an engineering discipline,
Hmm.
right? Where you can, build much easier systems from smaller components.
Okay, so the two next Databricks will be distributed compute across heterogeneous hardware and autonomous compound AI systems. Noted. I'd love to tug on another thread that you mentioned just now of kind of how funding constraints drive what you're working on. I'm curious what you think right now of, there's been a lot spoken about kind of the almost the brain drain in AI right now because the universities don't have the funding that you could get if you went to work at one of the big research labs. How do you think about that? What do you think is ideal? Does operating under constraints force creativity for you? Like, what do you make of all that?
Yeah, that's a great question. And It's true. I mean, it's challenging. It's very challenging. When I came to United States, I came to do my PhD, and I graduated from Carnegie Mellon University. I am originally from Romania. So one thing was admired, people admired about United States, is that how well um, the collaboration and the partnership, the three-way partnership between academia and government and industry are working, right? And prime examples at that time was obviously the internet, right, which was DARPA project, um, and of course academia had a huge impact, and also industry was whatever third industrial revolution people were saying. And that, when it comes to AI today, that kind of partnership is broken. It's like um, um, industries, every company is doing this research in silos, right? Even they don't talk to each other as much. Um, Academia, like you said, doesn't have resources, and the government doesn't invest as much, right? So I think that's some things to be very concerned about, right? Um, and That's why I'm also a big proponent of open source models.
Mm.
And US and California kind of will lose in long term if this is not fixed. So what happens now, unfortunately, in academia, one thing that happens is that, of course, there are some, bigger universities and labs which can still afford to maybe spend 1-2 millions maybe to train some models. It's still they are not in the same league like
Yeah.
OpenAI, right? It's like OpenAI and Microsoft they are talking about building the data centers about $100 billion, right? And I think there is the danger is that um, you are going to some of the academics are going to give up and try to innovate around the edges. Now, you can still innovate in this application and things like that, and I think there's a lot of innovations there. But clearly, it will be harder to come up with new model architectures and you know um, innovate. You know, have it will be harder. It's not impossible. Nothing is impossible. Um, so yes, it's a challenge right now. I mean, there are people like you know, and which are more fortunate position. Maybe I'm one of them, in which have access to resources outside academia, right? Um, but it's you do want to level the playing field in order to um, maximize the innovation. The innovation comes from everywhere. Uh, Now, this being said, it's true that scarcity, and always in the past, scarcity spurs innovation, right, as well. Um, but the concerns about uh, not having access to uh, resources to play the same game like in industry, it's a concern.
I'd love to switch gears into some rapid fire questions. If you're ready for it.
Sure, go ahead.
Will anyone take meaningful market share from NVIDIA over the next 5 years?
I think they will be at the minimum, because they are going to. It's probably that it's because Nvidia will not like to be accused about monopolistic behavior. So their market share has to decrease under some percentage, whatever, 70-80%. So that one will be one of the reasons. But I think that if I have to name one company to of course there are clouds, and for strategic reasons they are going to push their agenda to build their chips. Like still probably the biggest competitor right now in terms of the market share, it's Google with TPUs.
Yeah. Yeah.
Probably that will continue for a while.
Yeah.
What's one project or student in your lab right now that you'd want to highlight?
I'm going to cheat here because I think that both VLLM and Chatbot Arena has been
Hmm.
tremendous. It's like I'm not talking about SkyPilot because SkyPilot is like they started a company, so I'm not talking about. But I think VLLM has been amazing. It's like it's 1 year old project, and I've never seen such a rapid growth. And of course, it's also part of the AI. AI is kind of compressing the time.
Yep.
So there is something about that. And I think the other one is Chatbot Arena because it just is fascinating to see the development in the space
Yeah.
and to see how these different models, where they are strong, where they are weaker. And I think that having a front seat at that to see that kind of development in the of the ecosystem and in the space, it's fascinating.
Do you think the foundation models will commoditize?
The foundation model, whether they are,
Like a GPT-4 or a Claude?
yeah,
Do you
yeah.
think there's a market to be made in, providing these models over time, or do you think it commoditizes?
I think people will continue to build larger and larger models. I think though when it comes to serving, it looks like model distillations works quite well. By the way, the model is where you train a smaller model on the outputs from the bigger model. There has been a lot of success with that. By the way, this in some way, um, it says that it shows how important is the data, right, for training a model, right? Going back early on in our conversation, right? Because you have higher quality data from the big model, and you use that to train the
Yeah.
small model, and it's working very well.
Yeah.
So I think using multiple distillation models to reduce the cost of inference is going to be a way forward.
Hmm.
But yes, I think for advancing and pushing the frontier, so to speak, right? Uh, Pun intended. You are still going to see a lot of effort on bigger models.
What are you most excited to see in the world of AI in 1, 5, and 10 years?
What I'm most excited about AI.
Yeah.
Um, Look, there is no question it's transformational, right? I think that, and it's it will change a lot of things. Everything maybe. I think the most excited I am about it's about how do you make these AI more C systems more uh, predictable, accurate, verifiable. How you can debug these systems. This all of this is kind of in realm of software engineering, like techniques. This is what I think it's exciting.
What advice do you have for founders building in AI?
Um, it's the same thing, focus on the problem.
Yeah.
Don't focus on the hype. So hype is emotional.
Yeah.
It's not reliable. Just look at the facts, right? It's like, and look at the problem. Try to understand the problem and
Yeah.
try to be truthful to yourself. It's about, if you build an application, it's about production.
Yeah.
It's not about the demo.
Yeah.
Right? It's beyond the demo. Of course, the demo are important. Don't get me wrong, are very important. But the production, this is the mindset you have to have. And yeah, and it's the dangerous thing is there's so much hype, and you think you can solve everything and you can do everything, probably in certain number of years. But now just focus on exactly what problems you are going to solve. Convince yourself it's a good problem. Uh, Convince yourself that you can solve it, or at least you can have an MVP, right? You can solve a smaller version of that problem, which is still very valuable for your customers. Um, that's what I will say. Nothing, yeah, no silver bullet.
Amazing. Thank you so much, Jan, for joining us today. I've loved hearing a lot about your own thinking and reasoning behind your own journey. A lot of the thought process behind finding the right problem to solve, building the right systems to actually be in a position to understand the best problems, and then applying that even to many of the bold decisions that you've had to make in founding multiple companies from research into commercialization and the incredible success of Databricks today. Thank you.
Thank you for having me.